programming, we don't use them anymore. Very seldom do we use unions in object-oriented programming. However, they provide a backward compatibility to C, in which case unions were used all the time. All the time. There isn't a compiler out there that was written in C that didn't have unions all over the place. Okay? Another aspect of unions is memory saving. When we have, can you imagine having a machine that has 4K of RAM? I know that's difficult for you to imagine, but such machines did exist. And when we were in that environment, we would reuse memory all the time, redefine memory. Every language, C included, has the ability, has some syntax in it, to redefine memory. COBOL was called redefined. Fortran, it was called common. In C, it's called unions. And so that goes a little bit of history back to the 70s, where it was very, very important to maximize our use of memory. But then, as we move forward, and now we got machines that have 1 meg of RAM. Wow. We got all kinds of luxury. Now we're going to use unions for restructuring or being able to call an employee or back here a pay by one type and reference it 2 different ways. Okay. In C++ and object-oriented programming, we more often will see this implemented, this need to be able to say one thing and have it figure out which of 3 different things it actually is based upon what we call polymorphism, which is supported directly in classes. Okay? But its origins come back to unions and the union type with C. All right, that's enough of the history. Let's talk about some syntax. As I said, you won't use this, you probably won't see stuff that is written in C++ object-oriented programming. You won't see it very often. However, by the way, how many of you think that when you graduate, your employer, and you'll all have jobs, you'll go out and start working being the chief designer at Microsoft? Think it's going to happen?
No.
What do you think your first job's going to be? Take this old piece of code that's been around for 20 years and fix it. That's what your job's going to probably be. Make it work in today's environment, which means that you're going to have to read some old stuff. Okay? And then bring it up to speed with today's technologies. That's where you'll start. I don't know of any manager that would hire a new college grad and put them to work designing the brand new technology that's going to be the company gold mine going forward. Very, very few companies would ever do that. Maybe for an exceptional person, but few and far between. Most of the time, take the old code, bring it up to speed, and go ahead. All right, I digress. Here we have employee. And employee is this structure. Notice we have an enum type, manager, worker, salesperson, and that's this flag here. How big is flag? What's the size of flag? We don't know. It's probably a short integer, right? 0, 1, 2. Flag is of type emp type. It's an enum. and it's now part of this structure. Now part of the structure. We're going to use it in this example to decide which case to use. Okay? So we have an array of 15 sales, or 15 employees. They're all sales employees, maybe. Employee sales. And we choose which one it is, 0, 1, or 2. And then we bring in some data, or try to do some data, read some data in, based upon which one it is. So we bring in, let's say we have a 2, we bring in a 2, we enter a 2 in here, and notice the typecast, emp type. This thing is to emp type, it's an enum, and set the value of flag for that ith salesperson. Given that it's a 2, which is a salesperson, this switch statement is going to force us down to this one, in which case we do some cin, wages, sales, base. Is that okay to use in this structure? Is there such a thing as a base in this structure? Well, let's go back and look at the structure. We have wages as being the pay type. Now we've got to go way back, all the way up into here, to figure out what those are. We have a base here, but hourly pay doesn't even have a base. So it must be this kind, this type of a structure that we're working with. And we can bring that data in. It's okay to do so because the ith structure in this array has the flag set. We've determined it by salesperson, and so we're going to be setting data based upon this kind of a structure. Is that clear? If we wanted to restructure this same ith structure in the array, the ith one, and make a salesperson into a manager, in this chunk of code, all I would need to do is to change the flag to 0 and then set data according to salary. Managers are salaried. Same chunk of memory, different way we configure it. Is that clear? Questions there? Okay. Mostly, what I wanted to bring in today with respect to unions is this notion that I can take a reference and change what it refers to behind the scenes, right? That's a real important concept when we come to object-oriented programming. And also a bit of history to it. All right, let's move on. Chapter 14 is all about object-oriented programming. This is topics for next week. Okay, so we will get to